In 4.3, we're going to look at laws of logarithms. And since logarithms are exponents, if you remember back, to previous classes, you had laws of exponents or rules of exponents, whatever they're called. This gives rise to the laws of logarithms. And again, remember, A is not 1. So again, your base. Anytime we talk about the base in a logarithm, it's not 1. A, B, and C, the capital letters, can be any real numbers. And again, when we talk about real numbers, that includes variables. Okay, that includes x, that includes 2x, x plus 3. Those are truly all considered real numbers. And they're all going to be greater than 0. Okay, so we have law 1, which is the log of a product. So the logarithm of a product is the log of the first term plus log of the second term. So for an example, if I have the log of x times y, I can rewrite that as the log of x plus log of y. Okay, so just try to do your best just to apply the law. Look at what you got in front of you and then apply the appropriate law to that situation. If you have the log of a quotient, it's the log of the numerator minus the log of the denominator. So an example would be a logarithm of x over x minus 3, log x minus 3. That's all you can do with this. You can't do anything to this x minus 3 because the logarithm is not like multiplying. You're not multiplying. The logarithm is kind of like similar to the square root of x minus 3. There's nothing you can do with that. That's just what it is. The third law is the log of something raised to a power. So if we have the log of an item raised to a power, we can rewrite that as the exponent times the logarithm. So an example of that is log x plus 3 to the third power can be written as 3 times the log of x plus 3. So we're going to use these laws to expand single logarithms and to work our way back from multiple logarithms to single logarithms. So if I look at something like this, log base 2 of 16 of x, I can use law 1 and make this log base 2 16x equals log base 2 of 16 plus log base 2 of x. So then I look at each single logarithm now and say, okay, are there any laws that I can apply to these? And it's no. But what we can do here is we can replace log base 2 of 16 with 4. Because if you remember what we did in 4.2, log base 2 of 16 is 2 to what power gives you 16. So we could make this 4 plus log base 2 of x. Looking at the next example, I have log base 5 x cubed y to the 6th. So, I'm just going to work it from right here to make it easier on us. I can again use law 1. I can do log base 5 of x cubed plus log base 5 of y to the 6th. That's law 1. So again, I go back to each single log and say, okay, does it look like law 1, law 2, law 3, or none of them? And if you look at law 3, each single logarithm here does have a power. So what I can do is I can take 3 times the log base 5 of x plus 6 times the log base 5 of y. And that's all I can do with that. Okay, nothing more I can do. I can't anything. So I'm done. So you're just applying the laws of logarithms to each single log you have until you have done as much as you can. Now, this third one here, I'm going to kind of give myself some room. We've got a square root. So we've got log base A of x times the square root of x squared plus 1. So we still apply law 1 because this is a product. So I'm going to kind of take this over here and say this is log base A of x plus log base A square root of x squared plus 1. Nothing more I can do here. Now, it's been a few weeks, maybe even a few months, since we did square roots, but square roots can also be written as fractional exponents. So I can write the square root of x squared plus 1 as x squared plus 1 to the 1/2 power. And again, this is all so I can apply my laws of my logarithms. So I still can do nothing here, but to this logarithmic expression here, I can apply law 3. So I can say this is log base A of x. Take the exponent times the log. Now, you may be tempted to do something with this square, but you can't because it can't be factored. You can't pull the square root out, so there's nothing you can do with that, so we're done. That's as far as we can go. So that's applying law 1 and law 3 together. The next group of examples is going to be applying law 2 with law 3 and possibly law 2 with law 1 and law 3. But let's look here. We have a natural logarithm. Doesn't matter what type of logarithm it is. It's all the same as far as the laws go. And I have what looks like law 2. Numerator, denominator. So I just apply the law. Don't overthink these. Natural log x squared minus natural log x minus 1 cubed. Log of the numerator minus log of the denominator. Apply law 3. So I have 2 natural log x minus 3 natural log x minus 1. That's it. You're done. Because I go and I look at, again, each single log to see is there anything I can do, and none of these, either one of these two, look like any of my 3 laws. So I'm finished there. Moving on to this one. Okay, this one has a quotient, and in the numerator it's got a product. So when you have choices, we apply law 2 first. So go ahead and apply law 2, and I'm going to do the log of the numerator minus the log of the denominator. Oops. Sorry about that. And that is a 3 there. Now I look at each individual log, each single log, and say, okay, is there anything I can do with this? Well, this is still a product, so I can apply law 1 here. So this is going to be log x cubed plus log, and if you remember from the previous example, I'm going to make the square root of 1/2 power. Just kind of do 2 steps in one. So I've taken law 1 and did log A plus log B. Now I do not have any law 1s. I have no law 2s, but I do have several law 3 I can apply. So I can do 3 log x plus 1/2 log x squared plus 1 minus 4 log x plus 1. And that's it, as far as you can go. So you've separated it, and you have taken a single log and expanding it into sums and differences of more single logarithms. And you break it down until there's no more laws you can apply to it. Okay, so that's what we do when we expand. Now, when we work backwards, we want to combine sums and differences of logarithms into a single logarithm. So what we do with that is we reverse the steps we just did. So if you look here, we did law 1, then we did law 3. Okay, we did law 2, then we did law 3. So to put them back together again, you reverse the process. So we will apply law 3, and then apply law 1, and then apply law 2 if applicable. So depending on what we have here. So if I have 3 log x plus 1/2 log x plus 1, I am going to say, okay, this is log x cubed plus log x plus 1 to the 1/2 power. And I am going to make that 1/2 power back to a square root. Apply law 1 here, and I'm going from the right side of the laws to the left side of the laws. Okay, so what we're doing here, we are now going from what this looks like and putting it back into that. So I've got log A plus log B is the single log of A times B. And you're finished. So once we get it back into a single log, that's all we're doing. For example, 4, the only difference is now I've got a subtraction, which means I'm going to be doing law 2 eventually, but I must apply law 3 first. So this is my natural log of x minus 1 minus natural log of x plus 4 to the 3rd power. That's law 3, taking the number times the log and making it an exponent. And then I'm going to apply law 2, where I take law A over B. So natural log A over B, and you're finished. So that is that. Okay. Last thing I want to talk about is, is how to evaluate logarithms with bases other than 10 or e. We talked about your calculator. It is defaulted, and the common log is base 10. The natural log is base e. But there are other bases, kind of like the one we did earlier, log base 2 of 16. Well, here's your change of base formula. So, for instance, for that one we did earlier, well, if I wanted to find out what that number was, I take the log 16 divided by log 2. Now, on this calculator, I got to do everything backwards. So I do 16 log divided by 2 log, and I got to hit equals, and I get 4. Okay? I see students miss this all the time. They enter them backwards. Just look what I did. Log of the number divided by log of the base. So for log base 8 of 5, it's log 5 over log 8. So you need to be practicing these with me. And I get 5. Hold it. Let me try this again. Hit the wrong button. So I do 5 log divided by 8 log. Hit equals, and I get 0.77. And, that's how you check this is, what I'm saying is 8 to this power equals 5, okay, because this is the setup. And if you remember what we did the first day of logarithms, we took the logarithm form and changed it to the exponential. So to check, 8 to the 0.77 should be 5. And we can do that. 8 y to the x 0.77, 4.958. That's close enough because we rounded. Okay. So I want you to try the next one. Log 9 of 20. Log base 9 of 20. So this is log 20 divided by log 9, and just some caution, if you're using a calculator where you got to use parentheses, make sure you close them after the numerator, and you should get 1.36. Log base 5 of 125. See what you get for that one. Should be 3. And then lastly, log 150 over log 8. So log of the number divided by log of the base. So I do 150 log divided by 8 log, and I get 2.4. Okay, so make sure you know how to do this. I see this missed oftentimes, and it just doesn't need to be. And if you're not sure what to do, just ask me. Okay, so that wraps up 4.3. We will end there.